Geometry Unit 4 Lesson 1, I can classify triangles by their angles and sides. So to classify, we're going to put it in a group, and putting triangles in groups first by their angles. An acute triangle, if you were to go ahead and make an acute angle, maybe this, maybe call it 50 degrees. Okay, we know an acute angle, so an acute triangle would be just to close this off. And what you'll end up noticing is none of these angles are bigger than 90. They're all acute. So this could be 50, this could be 80, and this could be maybe 50 as well. But they're all going to be less than 90. So the definition of an acute triangle: triangle with all angles less than 90 degrees. They're all acute. Now, if we look at an obtuse triangle, go ahead and make yourself an obtuse angle. Maybe call this right here 110 degrees. And if you close this one, you have an obtuse triangle. Maybe this over here is 20, and who knows, maybe this over here is 50. But you'll notice there is exactly one obtuse angle in there, only one. So an obtuse triangle is a triangle with exactly one obtuse angle. And you can't have more than one because these have to sum up to 180. And since obtuse is bigger than 90, if you had two of these triangles angles bigger than 90, you'd be already over 180. There's not any degrees left over for the third. So now let's come over to a right triangle. It has a right angle in it. The other angles could be maybe 40 and 50, who knows. But a right triangle has exactly one right angle. So a triangle with exactly one 90-degree angle. And the others, if you notice, have to be acute. It can't be obtuse, that would be bigger than 90, and something bigger than 90 plus 90 is already over 180. It's not going to work. Last but not least, equiangular triangle. Equi means equal. Angular means angles. So for us here, that would be a triangle that has all of its angles congruent. And for that to happen, since they have to sum to 180, it's going to be 60, 60, 60. And it turns out if it's equiangular, it also becomes equilateral, which means this would be regular. So an equiangular triangle is a triangle with all angles congruent, and that means 60 degrees. It also, though, means it's going to be equilateral, so it'll be regular. So that's classifying by the number of the angle measures. We can also classify based on its sides. And if we take a quick look here, we're going to classify by the sides. Here's a word we've never seen before. It's pronounced scalene. Scalene. And scalene means all the sides, all the angles are different measures. So a scalene triangle might look like this. Maybe this side is 3, this is 5, this is 7. Who knows, maybe this is 30, this is 110, this is 40. But it's a triangle with all sides and angles different. That is scalene. Now, equilateral, we've already talked about equiangular. This means equal. And lateral, we know, means sides. So equilateral, all the sides will be the same. And if all the sides are the same, it turns out all the angles must also be the same, making 60, 60, 60. So the definition here is a triangle with all sides congruent. And finally, isosceles triangle. Isosceles. So an isosceles triangle is a little bit trickier. It's a lot like our isosceles trapezoid. The legs are congruent, and so are the base angles. Except here, we're going to call this, that's the vertex angle. And these here, these are the base angles. This is still a leg. This is still a leg. And so the definition of an isosceles triangle is a triangle with at least two congruent sides. So technically that means equilateral is isosceles, but we almost never refer to it that way. So it's at least two sides congruent. It makes the base angles congruent too. The vertex angle is the angle that's not congruent to another. Okay, so if we dive down here, you can hit pause and try and find some of these. We want to try and name some triangles. The way you name a triangle is you put a triangle symbol and then 1, 2, 3 letters. See if you can name an isosceles triangle. Okay, here I go. So an isosceles triangle, at least two sides congruent. So I'm going to look at this triangle right here because it has this side and this side congruent. So I'm going to say triangle ALH. Could have named it HAHL, LHA. Order doesn't matter there. But I can also say for isosceles FHL, this one here, because it just has to be at least two sides. So I can say triangle FHL, although this is really the one we're going to use the most when we only look at two sides congruent. Equilateral. So equilateral turns out to be this one here. And that is going to be triangle FHL. All three sides congruent. And finally a right triangle. This one turns out, the yellow one, triangle ALH, is right and isosceles. You can actually call it a right isosceles triangle. Okay, again, you can try the same thing over here, but we're going to classify these triangles slightly differently. You can hit pause and try it. All right, here I go. Scalene, all three sides of the triangle are different. Well, take a look, for example. I could come in and do this one. 1, 2, 3. That's a possibility. So maybe triangle RCK. Maybe you'd go RTK. Maybe you'd say triangle RCY, this one here. 1, 2, 3 different sides. And so forth. Let's look at isosceles. So that was scalene. Isosceles, remember at least two sides congruent. So I could come in and do this one here. That would work. Or maybe I'd come and do this one down there. So I'm going to say triangle CRT is this one here. Or I could say triangle CKT. Again, at least these two sides are congruent. At least these two sides are congruent. Here's the vertex angle for this triangle. Here's the vertex angle for this triangle. And finally, a right triangle. How about that one? We've got triangle RYT. You could also say triangle RYC because this is a linear pair, so this would have to be 90. For the same reason, you could say this is 90 and this is 90, so both of these would have been fine for right triangles as well. TYK or CYK. Okay, so remember, when we go to classify, look back at your notes frequently, and we can classify based on the angles or based on the number of sides. Good luck.